Okay, so now we are ready for, sorry, hang on, I gotta get out of the things out of the way. We're ready for completing the square. So before we talk about completing the square, this is basically undoing FOIL, so to speak. Okay, this is undoing the distribution. So I want to talk about how we distribute first, or aka how we FOIL. So if I have something like x plus 5 quantity squared, well, this is x plus 5 times x plus 5, right? And then FOIL or distribute, that's x squared plus 5x plus 5x, and then plus 25, which gives us x squared plus 10x plus 25. Okay, so notice that the 5x occurs twice, but gives us 10x. Again, if I have, let's say, x plus, I don't know, 8 quantity squared, again, that's x plus 8 times x plus 8, which is x times x, which is x squared, plus 8x plus 8x plus, what, 64, if my head can math. Y'all watch me. So that is x squared plus 16x plus 64. Okay, so that's one way to do it. But we want to work smarter, not harder. So if you notice the pattern, if I have a perfect square binomial, bi meaning two, so two terms, nomial meaning a term, monomial is one, binomial is two, trinomial is three. Okay, so perfect square, squared, binomial. We can use the pattern that if it's, say, x plus 2 quantity squared, the pattern is that to get the first term, you square the first term. To get the last term, you square the last term. To get the middle term, you combine and double. So combine 2x doubled is 4x. There you have it. So if I have x plus 7 quantity squared, that's x squared plus 14x plus 49. Combine and double. What if it's subtraction? What if it's x minus 6 quantity squared? Same thing. That's x squared plus 36, because a negative times a negative is a positive. The only difference here is now that you have the negative term in the middle. So that's negative 12x, because you combine and double. So the way I think about it in terms of completing the square, you're just doing backwards. So if I have, say, just this part right here, well, if I need to find the third term, or if I need to find how to get to the binomial, we just have to recognize that, okay, the x term is a combine and double, so we just undo that. So we split the x in the number and then divide by 2. So that would be a negative 6. Like here, if I just had x squared plus 16x, instead of combine and double, we split and divide. So that would just be 16 divided by 2 gives us 8. That's what all of this says. So if a is not 1, you want to take out the 1 from every term. You want to move over the current c value, make room for the new one. Add the new c value, c equaling b over 2 quantity squared to both sides. Factor the left side and simplify the right side. Solve using the square root property, which is all fine and dandy. But I mean, I kind of like my way. That's why I teach it my way. But if this works for you, I mean, go nuts. So what this says is we want x terms by itself. We want all x terms by themselves. So x squared plus 4x equals negative 1. Now I create what I call my quote skeleton. So I know that I need this to be a trinomial. So I have x squared plus 4x plus blank equals negative 1. But whatever we do to one side, we have to do to the other. So if I have a blank on the left, we have to pop a blank in the right. Now remember, the whole name of the game is that we're trying to find what was the perfect square binomial that gives us these front two terms. So the x drops, the operation drops. Now here's where we split and divide. So 4x now just becomes 4 and an x. So essentially ignore the x and you just divide the number by 2. That's 2 in this case. Then up and over, that's what is describing this b over 2 squared. Essentially, you just take this number and you square it. So that is a 4 and a 4. But whatever we add into the left, we have to also add into the right. Now we simplify to get 3. Now we just keep going with the square root property. So we square root both sides. So x plus 2 is equal to plus or minus root 3, and then subtract the 2. Negative 2 plus or minus root 3. Ta-da! Okay. So let's try this one here. Again, we want just x's on one side, numbers on the other. So 9x squared minus 6x equals 4. Here we have to have the x squared term to be 1. So that means we want to factor out the 9. So I have 9 times the x squared minus 6 over 9x equals 4. But this is also 9 times x squared minus 2/3 x equaling 4. Now we're ready for the quote skeleton, if you would. Okay. So this is 9 times x squared minus 2/3 x plus blank equals 4 plus blank. But keep in mind now, whatever blank goes here has to be multiplied by that outside 9. Okay. Because it's really 9 times all the terms inside the parentheses. Okay. So now it's 9. The 9 just is along for the ride. So x, the operation follows. So negative, negative. 2/3 divided by 2 is just 1/3. 1/3 squared is 1/9. 1/9 times 9 is just 1. That is equal to 5. And now we just finished using that square root property. It's pretty ugly, but I mean, it gets the job done. So this is x minus 1/3 quantity squared equals 5/9. Square root both sides, plus or minus 5/9. Oops, excuse me, square root. Now, up and over. The square root of 9 is 3. So we can simplify this to say that this is x minus 1/3 plus or minus root 5 over 3, right? Because the square root of 9 is 3. And now add 1/3. So x is equal to 1/3 plus, but actually plus or minus root 5 over 3. Since they're both over 3, we can say this is 1 plus or minus root 5 all over 3. Now the homework system should take both solutions. Okay, it should being the optional word there. All right, that's completing the square. Honestly, generally speaking, you're going to mainly work with things like this. To be quite honest, if I was asked to complete the square, I'd say, nothing. I don't want to do that. I don't want to deal with fractions. I don't want to deal with multiplying things. Like the messier, the no thanks. I would just skip to the quadratic formula if I was asked to solve something like this, personally speaking. This, yeah, I'll complete the square of this one all day long. No problem. But if I have an A term that's not 1, I'm honestly just going to go bloop, straight to the quadratic. Who are we kidding? So the quadratic formula you're probably familiar with, but if not, it is if ax squared plus bx plus c equals 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And what's pretty cool is that all this is, so from the standard term to the quadratic formula, it's completing the square. You actually just complete the square of the standard quadratic formula. That's pretty neat. So I am putting the 4ac in parentheses to make a note that you want to do the multiplication, excuse me, of 4ac and the square before you do the subtraction, right? So it's not b squared minus 4 times da, da, da. It's b squared 4ac multiplication and then the subtraction. So that is a big thing of note here. Okay, so solving using quadratic. Oh, sorry, let me put my phone on silent if y'all can hear that. So if I have 9x squared plus 3x minus 2, we want to get all our ducks in the row. A is with the x squared term, B is with the x, excuse me, and C is just the constant. So we want to note that A is 9, B is 3, and C is -2. So for your test, remember you get a note card. I would definitely put this on your note card if you're not already familiar with it. Okay, it really is just plug and chug if you know where to plug the numbers into. Excuse me. So we have that x is equal to, so -3. Oh, let me see if I can get them both on screen. There we go. Plus or minus b squared, so that is the square root of 9 minus 4 times 9 times -2 all over 2 times a, which is 9. So I have -3 plus or minus, we're just simplifying now. 9 minus, let's see. Hopefully, can you see the screen? Yeah. 4 times 9 times -2, which is -72. All over 2 times 9, which is 18. So the double negative makes it a positive. So this is -3 plus or minus the square root of 9 plus 72, right? Because the double negative, which is 81 over 18. Now the square root of 81 is what? 9. I'm going to circle back over here. So -3 plus or minus 9 over 18. Now 3 can go into all, well, actually here in this case, we have -3 plus 9. So -3 plus 9 is what? 6 over 18. -3 minus 9 is -12 over 18. And now we want to reduce. So this 6 goes into 18 3 times, that's 1/3. -12 and 18 both can go into 3, so that is what? -4, 4, 6. Oh, 6 can go into both of them. Hello, so that's 2 and 3, 2/3. This is why I need y'all here to stop me from doing these crazy things. So in this case, A, x is equal to 1/3 and -2/3. Ta-da! Okay, pause the video and try B. Come back, press play when you're ready. Let's see. So set in equal to 0. We have x squared plus x plus 2, so A is equal to 1, B is equal to 1, and C is equal to 2. So that means that I have -1, or x equals, plus or minus the square root of 1 minus 4ac, the 4 is stagnant, 4 is just there, all over 2 times a. And now we just simplify. So this is -1 plus or minus the square root of 1 minus 8 over 2. But hopefully you have a red flag that's popping up right here. That's -1 plus or minus the square root of -7 over 2. So if we only want real solutions, there's no real solutions. No real solutions, right? Because we have that negative under the root. However, we can get imaginary solutions, right? If we want imaginary, that would be -1 plus or minus I root 7 all over 2. So here we have two imaginary solutions. So 0 real versus 2 imaginary solutions, which brings us to the discriminant. The discriminant is the part underneath the square root for the quadratic formula. So the discriminant is b squared minus 4ac. Because it's under the square root, it tells us the number and nature of solutions. So if the value is positive, then we have 2 real solutions. If it's 0, then we have 1 real solution. If it's negative, then we have 0 real solutions. And again, if it's negative, or 2 imaginary. Just like the last example that we did. So positive, we have 2 real. Just like this one, right? 2 real solutions. Whether it ends up nicely like this, like 1/3 and negative 2/3, or kind of like messy with a root in it. 0 meaning that the whole the square root term would disappear and we just have like negative 1/2, so to speak, if this part is 0. So let's look at a few examples. Okay, so we're just determining the discriminant and then stating how many solutions there are and the nature of the solution. We are not solving. Okay, keep in mind the discriminant is just b squared minus 4ac. So first we want to set everything equal to 0 if it's not already. And then we just pop it into here and we just want to know, is it positive, 0, or negative? So pause the video and I want you to try on your own. Okay, so if x squared plus 4x plus 7 equals 0, so a is equal to 1, b is equal to 4, and c is equal to 7. So I have 16 minus 4 times 1 times 7. 16 minus 28. Well, that is a negative number. Okay. So in this case, there's 0 real, but 2 imaginary. If we do b, a is 2, b is equal to negative 9, and c is equal to 7. So again, we have b squared, so that's 81, minus 4 times 2 times 7. So this is 81 minus, let's see, 4 times 2 is 8, times 7 is 56. This is equal to a positive. So I have 2 real solutions. So far, so good? All right, and C. A is 9, B is 30, and C is 25. Okay, so 30 squared, 3 times 3 is 9, with 2 zeros behind it. So it's 900 minus 4 times 9 times 25. Well, 4 times 25 is 100, times 9 is 900. That's 900 minus 900, which is 0. That means we have 1 real solution. And again, just so that you can see what we mean by 1 real solution, this is, so negative 30 plus or minus root 0, right? Because we just found out what the discriminant is, over 2a, or 18. So this is just negative 30 over 18, and then we would reduce and go from there, right? So 6 can go into both these. That's negative 5 over 3. is what that solution would be. So that's what we say. That's what we mean when we say one real solution. Since the discriminant is 0, you don't have the plus minus term. Okay. And last but not least, the word problem. A formula for the normal systolic blood pressure for a man age A, measured in, I have no idea, mmHg. Hopefully one of you are smarter than me and know what that means. Is given as cap P equals 0.006 cap A squared minus 0.02 cap A plus 120. Find the age to the nearest year of a man whose normal blood pressure measures 125. Okay, so first we have to identify where's the 125 going. Well, look at the unit. So it's the mmHg, right? So that means that is the P for the pressure, right? Blood pressure. So the whole thing is getting set to 125, and we are solving for A. Okay, now, since we're working with decimals, I am just going to go straight into quadratic, right? This would not be fun to complete the square because that's not a 1. We'd have to factor out a 0.006, and my brain just can't factor like that. So we're just going to go straight into the quadratic. Work smarter, not harder. Okay. So we are subtracting 125 over, so that would be a -5. So this is where in class I would need your help. A is 0.006, B is -0.02, and C is equal to -5. So we're just going to pop this into the quadratic formula. So negative B, so negative is a positive 0.02 plus or minus the square root of 0.02 squared. Let's see. E to the -4th means that I have 0 and then 4 zeros ahead of it. Oh, yeah, 1, 2, 3, 4. Yes. Right. So if I have 0.0004, perfect. So basically, there's 4 spaces between my 0 and my number. Now, minus 4 times A, 0.006 times C. Oops, send that out. 4 times -5. Oops. 4 times 0.006 times -5 is 0.12. We'll get there in a second. Okay, so it says cap A is equal to all over 2A, 0.006 times 2, 0.012. Okay, so 0.02 plus or minus the square root of 0.0004 plus 0.12, right? Because of the double negative there. Yeah. All over 0.012. Okay, so 0.0004 plus 0.12 is equal to, yes, 0.1204, 0.02 plus or minus the square root of 0.1204 over 0.012. Let's see if we can just get lucky and see if this is a square root. I doubt it, but I mean, let's just see. Stranger things have happened. That's okay. We'll just use the decimal approximation. Okay. So I have 0.02 plus or minus the square root of 0.34, we'll say 7 over 0.012. Okay. So the two numbers, 0.02 plus 0.34 0.347 divided by 0.012 is 30.58. So that could be a potential age. And 0.02 minus 0.347 divided by 0.012, negative 27.25. Does that make sense? Is a man going to be negative age? No. So the only answer is about 30 and a half years old. Perfect. Nice. And I'm happy to answer questions about these in class or office hours. But that is it for the video. Y'all have an awesome day, and I will see you next time.